non-inertial frames of reference, or accelerating frames of reference. In a previous video or lesson, we discussed how all of our motion is relative to some frame of reference. We think of ourselves sitting still while we're watching this video, but we're actually on the Earth, and the Earth is rotating once a day and orbiting the Sun, and those are pretty significant velocities. So the reason we feel like we're sitting still is because we're comparing ourselves to our room. Our room is our frame of reference. As long as the frame of reference we're comparing ourselves to is moving with a constant velocity, we don't notice anything funny happening. Imagine, for example, that you're on a train and the train is moving along the tracks at 80 kilometers an hour, perfectly constant velocity. There's no forces required to have you maintain that velocity with the train. Objects in motion tend to stay in motion unless acted on by an unbalanced force. So you're going to keep going at 80 kilometers an hour, and so nothing needs to push you to make that happen. What that means then is it feels 80 kilometers an hour in a train feels just like standing still. An interesting thing, though, happens when you either accelerate, you speed up, or you slow down. We've all experienced this as well. If you're on the train, so here's the train, and here you are, and let's say you didn't get a seat, so you're stuck holding that pole. And the train was going at 50 kilometers an hour when all of a sudden it had to come to a stop. So the forces of the brakes act on the train. But those same brakes don't act on you directly. So what you feel is you feel yourself lurch forward. What's really happening is you're maintaining your speed of 50 kilometers an hour, and then to make that change to rest, you have to find a way to apply a backwards force or braking force on yourself to allow yourself to slow down. That's why you hold on to the pole. That being said, from your perspective, if you forget about this motion and you're looking at everything just from the train's perspective, then this doesn't seem like you're maintaining your speed. It seems like all of a sudden you lurch forward. If we want to work with that, we can. What we have to do is we have to introduce something called a centrifugal force. This is a fictitious force. Fictitious, so it doesn't really exist. Force that is caused by an acceleration in the frame of reference. You're moving along, the train's moving along, the train stops, and now your frame of reference, the train, is accelerating. You feel like you lurch forward. You feel like you're subject to some sort of force, but you're not really. It's just that you were trying to maintain your motion in a system that was not maintaining its motion. This centrifugal force is equal to the acceleration of the frame times your mass. So F, and I'll call it CEN so that we know that it's not centripetal, it's a slightly different thing, is equal to the mass of the object times the acceleration of the frame. This allows you to do physics from a accelerating frame of reference. It's not really necessary, but it's one way to look at problems. With that in mind, I'm going to do a couple of problems that show how this can be used to do physics from the perspective of an accelerating frame of reference, or I'm going to show you how if you just did the physics from a inertial frame of reference, a non-accelerating frame of reference, you'll get the same result, or it works. I'm going to do those in a follow-up video.